So today we're going to deal with a very popular integral. Now, personally, as a math major, I would tell you that I've seen this several times already. Yep, I've seen it popped up in pop quizzes and also in exams. So this is an integral that I'm pretty sure your teacher and your professors are going to put on your exams and your pop quizzes. So I would highly recommend that you memorize this and just know how to do it overall, really. So the unique thing about this integral is that it requires a method called integration by parts to solve it. You can't just go directly to it. So the equation for integration by parts, so it's the integral of u dv equal u times v integral of v du. So when it comes to solving problems of integration by parts, I always ask myself, okay, which out of this whole entire thing here, out of the entire integral here, what will be easier to get the derivative of and what will be easier to get the integral of? And you have to be quite careful when you select what you choose to get the integral of and what you choose to get the derivative of, because that can either make your problem easy or it can make it more difficult. So I can just go ahead and tell you now, it'll be much easier to just get the derivative of inverse tangent, because we know that the derivative of inverse tangent is 1 plus x squared under 1. And to get the integral of dx, which really, think of it as 1 times dx. So really we're getting the integral of 1. And we know that the integral of that constant will be x. So now we got our u's, du's, and dv's and v's. So we got that figured out. So that's good. So now at this point, we can literally just start plugging in our stuff here. So I'm not going to write this out here. I'm just going to write I here just to save some space here. But the I represents this part here, which is the integral here. So we're going to plug in our u, which is the inverse tangent, and we have to plug in our v's, which we know our v is equal to x and our u is equal to inverse tangent. So just for aesthetics here, I'm going to put the x first. And then we have to subtract integral, and now we're going to plug in our v du. Now we know v is equal to x and du is equal to 1 plus x squared under 1. So it'll look like this. Dx. So our next step here would just be to move some things around here. Now the x multiplies to the 1, so then that will give us this here, dx. So now we're going to go back up here. And honestly, if you know for a fact that, you could have skipped this part, I would have just skipped it, and like not take up so much space here. So now the next thing we got to do here is we have to employ a u substitution. So what we're going to do now is that we're going to set this bad boy here equal to u. Okay, so what I'm saying here is that when I get the derivative of this and then start plugging in stuff, because when I get the derivative, I want something that matches this right here. So let me show you what I mean by that. So we're going to set u equal to 1 plus x squared. The derivative of that would be 2x dx. Now there's no 2 here, so how do we get rid of that? How can I make this very familiar to xc that we have here? We'll just divide by 2 here. We cancel these 2's, and then we're left with 1/2 du equals x dx. So now we're in business, because now this right here matches up to what we have right here. So now we're good. So now at this point, we can once again just start plugging things in again. So we're going to go back to our equation here. It'll be x, the inverse. Now, because we do have this 1/2, honestly, well, here, let me just not get ahead of myself. To just set it up, times du. That was really bad too. Let me fix that. There we go. I have the worst handwriting. So because we have a constant here, we can go ahead and pull that out of the integral. And you will see what I mean right now. It will be much easier to work with now. And really, I would just pull out the du out of the place there, out of the way there. So that way we have this, and you're about to see why. So now that we got this here, all we really got to do now is just integrate this part right here. Now, remember that when you have 1 over x, the integral of that is natural log x plus your constant, right? So in this case, it's going to be the same thing, except instead of the x, we're going to have a u. So that's going to give us 1/2. We integrate this part here. We integrate this right here. Natural log u plus the constant of integration. But we're not done yet. We have to replace our u here, because remember, we did a u substitution right here. So literally, what's going to go in there is this right here, the 1 plus x squared. So then our final answer would be x times inverse tangent and there you go. And our final answer is now is x times inverse tangent minus 1/2 times the natural log, and then the inside we're going to have what we had in our u substitution, and that's your answer.